Generative AI tools are deeply embedded in our daily digital workflows. We type a question into a chat window and expect an immediate, helpful response. Most people treat these interfaces like traditional search engines, assuming the machine is simply retrieving a pre-existing answer from a vast library. In reality, every response is a unique act of synthesis. The machine is actively assembling a brand new piece of content on the fly, using raw data particles to build something that never existed before. This process remains dormant until a human provides a specific instruction. The machine holds no inherent power or direction without our input. The quality of the final result scales directly with the quality of the instruction. Vague commands produce generic, unusable data, while highly detailed prompts unlock sophisticated, high-quality responses. Mastering this technology is less about learning to write code and more about learning to communicate your exact intent to the machine. This method of high-level communication is known as prompt engineering. It is the new language required to operate generative systems effectively. Every interaction starts with a prompt, the specific written instructions or raw input we feed the AI to trigger a response. To steer these engines with precision, we use the RTF framework. By breaking our intent down into role, task, and format, we eliminate the machine's need to guess what we want. The R represents the role. Assigning a specific persona, like a professor, forces the AI to adopt a focused perspective and narrows the scope of the data it uses to build its answer. T is for the task. This is the concrete action we want the engine to perform, such as explaining the water cycle. This provides the AI with a clear, measurable goal. Finally, the F dictates the format. This instruction shapes the final structure of the information, whether it's a detailed essay or 3 concise bullet points. This structured framework acts as a steering wheel, allowing us to translate human thought into machine-readable instructions that maximize the AI's power. Once a prompt is submitted, it enters the processing engine, the large language model, or LLM. An LLM is an AI model trained on trillions of words to recognize and predict linguistic patterns. Most of us interact with these massive LLM engines through consumer-facing interfaces like ChatGPT, Google Gemini, or Microsoft Copilot. The sheer scale of these models is staggering. They process over 8 trillion words every single month to map the complex relationships between phrases and ideas. These systems operate purely on mathematical probability rather than conceptual understanding. If a prompt reads peanut butter and, the engine calculates that the word jelly has the highest statistical probability of coming next. The engine repeats these probability calculations millions of times per second, rapidly synthesizing strings of words to construct a coherent response. We call this final result the output. It is synthetic content, whether text, images, or code, that convincingly mimic human creativity. This mathematical prediction of patterns is what creates the convincing illusion of human intelligence, even though the process is entirely driven by statistics. Because LLMs build their patterns from the vast, unfiltered data of the internet, their outputs contain inherent structural flaws that can mislead us. These system errors are known as hallucinations. As detailed here, hallucinations occur when the AI generates false facts or fake citations with total confidence. The resulting data appears highly credible but is factually hollow. This happens because the model is programmed to prioritize linguistic fluency and pattern completion over factual accuracy. The authoritative tone used by these tools is merely a product of their training, meaning we must critically verify every output before we use it. The second major vulnerability in these engines is the absorption of human bias. Since the AI learns entirely from human-created data, it inevitably reproduces the stereotypes, inequalities, and flaws present in its training material. This shift mirrors the automobile's history. Early cars were a massive leap forward that required systemic guardrails, like traffic lights and seatbelts, to maintain human control. Generative AI functions as a co-pilot, an empowerment tool that enhances our capabilities while remaining dependent on constant human oversight. Operating in this new landscape requires 2 essential skills: using structured frameworks like RTF to steer the engine, and critically interrogating every output to identify bias or errors. The machine provides the raw generating power, but the human remains the essential quality controller. The ultimate authority stays in our hands.